Okay, for next question, it's given that a 3 kg block, as shown in figure, has a speed of 2 meter per second at A and 6 meter per second at B, and the distance from A to B along the curve is 12 meter. How large a friction force X on it? So that means we have to find the force of friction. And next is assuming the same friction, how far from B will it drop? So let's just stick to the first part where we'll have to find the force of friction acting on this. Now, if we consider the forces acting on this block, the weight is acting vertically downwards, and let's say this block is here. So its weight is acting vertically downwards. Normal direction is perpendicular to the path, and this is balanced by the rectangular components of mg. So this is theta, this is mg cos theta, and this is mg sine theta. Now the work done by the normal direction is zero because the displacement is in this direction. So these are the three forces acting: the normal reaction, and also the force of friction is in the opposite direction. This is the force of friction, let's say. So normal direction, the force of friction, and the gravitational force. So the gravitational force is acting vertically downwards. This is the gravitational force. So the net work done will be by these forces: the normal direction force, and force of friction, and the gravitational force. So let's calculate the work done by the normal direction. So work done by normal direction would be equal to its force into displacement into cos of theta. Now the angle between normal direction and the displacement will always be 90 degree. So the work done by this is force into displacement into cos 90, and we know that cos 90 is zero. So work done by normal is zero. So we can just ignore this one. Now we have to find the net work done, which is done by the force of friction and the gravitational force. So the net work done is done by the force of friction and the gravitational force. Before that, let's write down the information that we have. The velocity at point A is 2 meter per second. Velocity at point B is 6 meter per second. So, and also the height at A is 4 meter. The height at point B is 1 meter. Now, the distance covered from A to is 12 meter along the curve. This is along the curve. This is the distance covered by the block from A to B along the curve. And let's say the frictional force is F. F is the frictional force. Okay, now we have calculated the work done by the normal, which is zero. So let's focus on the net work done. So net work is done by this work is done by the gravitational force and the force of friction. And we know that the work done is equal to change in kinetic energy. So in this, we can substitute this with the change in kinetic energy. So that is equal to work done by the gravitational force. And we know that the work done by the gravitational force is negative of the change in kinetic energy. So I can write here negative of the change in kinetic energy and work done by the force of friction. We have to find out so that we can calculate the force of friction. Now I can write it from this equation. I can write it as work done by the force of friction is equal to change in kinetic energy plus change in potential energy. So I'm going to use this equation. Uh, let's replace in the values. So work done by the force of friction now that is equal to change in energy, which is equal to final kinetic energy, and final kinetic energy is at point B. So this is half into m into velocity of B. This is half into m into velocity at A. So this is the change in kinetic energy. Now we have to put in the value of the change in potential energy, which is the potential energy at point B minus the potential energy at point A. Okay, if we replace these values, so work done by the force of friction is equal to half into m. Now velocity at B is 6, so 6 squared is 36, and mass is 3, so I'm going to replace that with 3. So 3 into velocity of B is 6, so square of 6 is 36, minus half into 3 into velocity at A is 2. So 2 square is 4 plus 3 into g into height at B is 1 minus 3 into g into height at A is 4. So work done by force of friction is equal to 2, it is 18, and 18 threes are is 54 minus 2 twos are 4, 3 twos are 6 plus 3g minus 12g. Now 54 minus 6 is 48, 3g minus 12g is, this is minus 9g, and let's put in the value of g, which has to be 9.8 meter per second square. So this is 48 minus 9.8 into 9 is 9 8 that is 72, 9 9 are 81, and 7 is 88.2. So which gives us the value as, this is work done by the force of friction is equal to, this is negative, and this is 40.2 joule. Okay, now we have to find the force of friction. So work done by the force of friction, we know that the formula for the work done is equal to force into displacement. So this is force into displacement from A to B, and cos of friction and the displacement are both in the opposite direction. So this is cos of 180, that is the angle between the force of friction. So force of friction, this is force of friction, and the displacement for A to B. So displacement and the force of friction both are in opposite direction. So between them angle is 180. So it's cos of 180 minus 40.2 joule. Cos 180 is negative 1. So force of friction and displacement from A to B along the curve is 12, is equal to minus 40.2 joule. So this gets cancelled, and F is equal to force of friction is equal to minus 40.2 divided by 12, which should give me the value. So this is 40.2 divided by 12, that is equal to 3.35. So this is 3.35 Newton. So this is the force of friction. And let's move on to the next uh, part, which says that we have to assume the same friction, that is, let's keep this friction as it is, and now the object, assuming the same friction, how far from B will it drop? So if the force of friction is the same, so this object is moving along the curve, and let's say it stops at this position, that is C. So velocity at C, because it stops, so velocity at C is 0. And also the height at C is 0, because it is along the curve. We have to find this distance, how far it has moved when the force friction remains the same. So we are going to use this very equation, work done by the force of friction is equal to change in kinetic energy plus change in potential energy. So for the second part, work done by the force of friction is equal to the change in kinetic energy plus change in potential energy. And for us now, the initial and the final positions are B and C. So B is the initial position and C is the final position. velocity at c is 0. Okay, so let's try to calculate this. And so this is the change in kinetic energy. So change in kinetic energy is the kinetic energy at final position, that is C, minus the kinetic energy at B. And the change in potential energy is potential energy at C minus potential energy at B. So kinetic energy at C will be 0 because at C it stops. So this is 0 because here the velocity at C is 0. Now the kinetic energy at B is half into 3 into velocity at B. So velocity at B is 6 meter per second square. So 6 square is 36. And now the potential energy here also the velocity is 0. So the potential energy at C is, oh, sorry, it's not the velocity, it's the height. Velocity is also 0, but the height at C is 0. So the potential energy is 0. And minus the potential energies at B is m into, this is 3. 3 into g is 9.8. And the height at B is 1 meter. So this is 18. And finally, we have minus 54 minus uh, so this is minus 54, and 8 threes are is 24, 9 threes are 27, and 2 is 29.4 joule. This is the work done by the force of friction while moving from B to C. So minus 54 minus 29.4. 54 plus 29.4. This gives me 83.4. So this is negative 83.4 joule. Okay, work done by the force of friction is the force of friction into displacement from B to C into uh, cos of 180 degree, because that is force of friction and the displacement both are in the opposite direction, and cos of 180 is minus 1. So this is equal to negative 83.4 joule. And it's given that we have to assume the force of friction to be same. So let's take the force of friction as 3.35. So 3.35, and we have to find the distance. It's moved from B to C. Negative negative gets cancelled, and distance it moved from B to C is equal to 83.4 divided by 3.35. So 83.4 and divided by 3.35. So 83.4 divided by 3.35 is equal to 24.89. So this is 24.89 meter. So 24.89 meter is the distance it moved from B to C, assuming the same force of friction. So we have calculated the distance that moved from B to C, and the force of friction is 3.35 Newton. Thank you for watching.